Hey class, hope you guys are doing okay at home. I miss you guys. It's really weird teaching to an empty classroom, but anyway, we are going to spend one more day on the applications of the parabola. This tends to be one of the hardest things, so I just want to give you guys enough time for this. So we're going to do two examples today. I'm going to do an example about a satellite and an example about a bridge. And then just know that next week we're going to start a new shape called the ellipse. And then we will combine the two together. So make sure you're really solid on the parabola this week before we head into Monday, okay? All right, so the first problem, I don't have a worksheet for this, so just get out a piece of paper. You will also need a calculator, okay? Is we're gonna talk about just a satellite. We're gonna have a satellite and we wanna find out where the receiver is, okay? If I don't give you a picture, if the book doesn't give you a picture, then you get to decide which way you want that satellite to open. The two ways that most kids pick are opening right and opening up because those don't have negatives in them. And it's kind of weird to have a satellite opening down. I mean, that's just never gonna happen. So you can kind of pick your favorite direction. I kind of tend to go up whenever I can. It just seems a little bit easier for me to work with, but it's of course up to you. So this is my satellite. And then a satellite has a receiver to receive information, and that's gonna go at the focus. So one thing you really have to understand is when I say where's the receiver, that means where's the focus. But I don't really know where the focus is, so I don't wanna draw it and have it be wrong, so I'm just gonna kind of hold off on that. Okay, so my general question is where is the receiver? That's the question we're trying to answer. Okay. So what I'm going to tell you is I'm going to tell you the dimension. So I'll say something like it's 12 feet wide at the opening. So what that means is that the opening, which is here, is 12 feet. Okay. And then it'll say something like the depth. Okay. That means the biggest depth, not just any depth. So that means that this depth is 2 feet, which also makes this 2 feet from here to here, of course, and also this is 2 feet. Okay, so that means that that's like if you had a bowl, it'd be like how shallow it is, okay? All right, so what you want to do is start by writing your equation, of course. The equation of a parabola opening up with a vertex at 0, 0 is just x squared equals 4ay. Okay, the h and k are gone because the vertex is 0, 0. Okay, so if I ask to find the receiver, hopefully you guys understand that I'm asking you basically to find a. If you don't know a in a parabola, you have to plug in a point to find it. So if you look at your picture, there has to be one of these points right here you have to know. And you can't use the vertex again, by the way. You won't get an answer to that. So if you go along the curve like this, what you'll realize, hopefully, is that you do actually know this point right here, okay? Because if this is 12, that means this is 6 right here, because it's symmetrical, of course. So this is 6, this is 2, which makes this the point 6, 2. Okay, so if you have a point, then you can plug that in. So you get 36 equals 4 times a times y. You get 36 equals 8a. Okay. You can divide these both by 4 and get 9 halves. So a is either 9 halves or 4 1/2. Okay, and remember the significance of that is you would say that the receiver is 4 1/2 feet from the vertex. Okay, so if you look at your picture, this is only 2. That means the receiver is quite up here. I don't really have space to put that. This is the receiver, okay, which hopefully makes sense to you. So what happens is the rays come down, hit off the bowl of the parabola and bounce to the receiver, therefore maximizing the signal, and this will be like receiving the information that you wanted to get, okay? All right, so I'm gonna erase my board. The next problem we're gonna do is gonna be about a bridge, okay? Alrighty, so in this one, actually I said it's about a bridge, but I'm wrong. It's about a tunnel. So if you drive to San Francisco, you know, there's tunnels that take you underneath the mountain. One of them has that rainbow on it, and they call it the Robin Williams Tunnel. That's not a parabolic tunnel. That's a semi-elliptical tunnel. But there are other tunnels that are parabolic, so we are gonna pretend that our tunnel is a parabola, okay? So a tunnel, of course, looks like this, okay? and you drive underneath the tunnel, you know, the one in San Francisco goes like this, and then has that pretty rainbow drawn on it, okay, like that, okay? So of course, in this class, we want to put everything on an XY axis, and this one I'm going to do a little different. If I let you choose your axis, okay, then you could put the tunnel here, and this would be the vertex, okay? But you can also put it here and have this be the vertex, okay? Sometimes I will let you choose. Today, I'm not going to let you choose. I'm going to pick it for you. What would be a bad idea is to have the tunnel underneath the ground like this. You do not want your tunnel underneath the ground because then all these values will be negative and it's really confusing, okay? So either pick this one or this one if you have a choice. Today, you don't have a choice, okay? Today, what I want you guys to do is I want you to draw an XY axis like this, okay? And I want you guys to draw your tunnel so that one of the points is right here at 0, 0. Okay, and again, sometimes they force you to have an axis at a certain spot, and sometimes they let you pick. Okay, so here's some information about my tunnel. Okay, my tunnel is 120 feet span. Anytime you see the word span, it means that the biggest opening is 120 feet, like this. Okay, and then it'll say something like the highest point or the highest clearance is 80 feet. Okay, so obviously that means that this is 80, because that's the tallest that it gets. Okay, so that's some information about our tunnel. Okay, so just like always, first thing you do is you write down the equation of a parabola opening down. And this one does not have a vertex at 0, 0, so we do have to use the h's and the k's. So opening down is x minus h squared equals negative 4ay minus k. All right. The vertex is always what you fill in first. The vertex is, in this problem, right here, okay? So, from here, how far is it to here, and how high up is it, okay? If this is 120, the vertex is, of course, in the middle, so this would be 60, and of course, this is 80. So your vertex is at 60, 80, okay? You always want to fill that part in first, okay? So you're going to go ahead and plug in 60 for h and 80 for k. So x minus 60 squared equals negative 4a minus 80. Okay, so now in order to have an equation, you do have to fill in a. And a is obviously not given to you. There's no reason to give you a focus of a bridge. It doesn't have any meaning, but you still have to find a to have an equation. So remember, when you don't know a and you want to try to find it, the only way to do that is to plug in a different point that's not the vertex, okay? So what you have to do is you have to go along this parabola and say, what other point do I know besides this one? And this one, you actually happen to know two. This one is 0, 0, and this one is 120, 0. It doesn't matter which one you plug in. I promise you, you'll get the same answer either way, okay? But I'm going to use 0, 0 because it just feels easier. So now what I'm going to do is I'm going to plug in the point 0, 0. So 0 there and 0 there leaves you with negative 60 squared equals negative 4a times negative 80. This is 3,600. This is 320a. Divide. Okay. And you can type that into your calculator. Let me just make sure I have that right. Hold on. So you do 3,600 divided by 320, and you get 11.25. Okay, so in order to have an equation, you need to plug that back into here, so right there. And so my equation, I'll just write it up here, is x minus 60 squared equals negative 4 times a is negative 45, and then you get y minus 80. Okay. All right. So hopefully you understood that. I'm going to ask you a question now that I want you guys to try to answer on your own, and then you can, pause the video and see if you got it right. All right. So my question for you is, okay, how tall is the tunnel? Okay, 10 feet from the edge. So I will give you the answer, but I want you to just pause this and try to do it on your own first, okay? All right, so this is how you do it. It's 10 feet from the edge. I would draw it on your picture. 10 feet over from the edge would be here. Of course, it would also be here, but those answers are symmetrical, so you don't have to do both, okay? You have to figure out, what am I giving you? Do you know X or do you know Y? So if it's 10 feet from the edge, that means I'm telling you that this X value is 10, and what you don't know is how tall it is, which is the Y. So all you have to do is take your equation and plug in 10 for the X value. Okay, and then you just solve that. Okay, just use order of operations. So 10 minus 60 is negative 50, and then negative 50 squared equals negative 45y minus 80. Okay, all right, so you're gonna square this first. Okay, then you're gonna divide by the number in front. Okay, and you will get a negative number for that. I don't remember what the number is, hold on. 2,500 divided by negative 45. Hold on, typed it in wrong. So it might feel weird that this is negative, but the reason it's negative is because you still have to add 80, okay? And you get 24.444 feet, okay? So go over to your picture, and this means that this is 24.444 feet, which may be important to know if you have like a big truck and you want to know if you'll fit through the tunnel or not. All right, group. So I think it's Friday for you guys. If it is, have a great weekend, and I will be in touch with you on Monday. Okay, take care, you guys. I really miss you. Bye.